Alright, so I'm going to go over the study guide for exploratory data analysis tests. So remember, this will look just like your test, but with some different values. So as long as you go through this, you actually follow along, you take notes, you ask me for help when you have them, you should be fine on the test. So your learning target, I can study for my test and hopefully pass. Oh, it says hopefully test. That's embarrassing. Let's go with pass. Alright, so high school students are surveyed, describe 2 categorical and 2 quantitative variables that might be used to identify students. So remember, categorical is words, sorry for that, and then quantitative is numbers. Alright, so these will vary. For categorical, I'm going to say name, because that's just, a word. And then maybe gender, if you wanted to break stuff up into male and female. You could look at grade level, because that's a number. And then maybe, I don't know, something like GPA. So that might be some things if high school students are observed. Categorical, words, quantitative, numbers. Alright. We also talked about something called marginal distribution. You can go back and watch those videos if you need to. So if I look at all these, I can add all these up, and I get 400. So when I do the marginal distribution for telepathy, I would add those 2 numbers, 44 and 50. So 94 over 400. And if I change that to a percentage, it's 23.5%. Invisibility, I would add 32 and 64. So 96 over 400. Change that to a percentage, so 24%. Flying, I would add the 2 numbers out of 400, change it to a percentage, 14.25%. For force field, add the 2 numbers, let's see, 43 out of 400, so 10.75%. And then telekinesis, add the 2 numbers, so 110 out of 400. And that is 27.5%. So that is how you do marginal distributions, and you're usually going to put them in percentages. If I want you to put them somewhere else, I'll tell you. Alright, now we're going to use the table that we just did to calculate the following. So the percent of people in France who prefer force fields. You just read the table. So if you look at people in France that like force fields, okay, so that's definitely 30, and it does say people in France, so you have to add up all the people who are in France, which is 230, so your bottom number changes, but you should get about 13%. Alright, so part B, the percent of people in the U.S. who prefer flying, so that is 26. I'm going to have to add up all the people in the U.S., get 170, and if I change this to a percentage, I get 15%. Alright. And then the last one, the percent of people in France who prefer telepathy or invisibility. Alright, so that's 50 plus 64 out of everybody in France, 230. So that's about 49.6%. And so if you're typing in answers on a test, I'll tell you exactly how many decimals to round it to. Alright, number 4. The most popular bicycle colors change over time. Below is the distribution of colors for the bicycles sold in Canada in 2008. So you can read through this if you want to, and try the questions and do it in 1, 2, 3. Alright, so for part A, what a percent of the bicycles sold were in the other category. So notice this is in percentages, and so out of 100% should be everything. So if I do 100 minus all the other numbers, I get 16. So this is how I get 16% down here. Alright, next one, it wants you to display the data in a bar graph. And we've already talked about how to do that. Remember, bar graphs are not going to be straight beside each other. Those are histograms. So very quickly, I'm going to do a little bar graph. Alright, so it should look like this. Doesn't have to be that perfect. Everything labeled, accurate, not touching. I'm going to make it a lot smaller, but it's over here if you need it. Alright, and then would it be appropriate to display in a pie chart? I think it would be appropriate because everything adds up to 100%, which is what you want a pie chart to do. So yeah, it's perfect. perfectly fine. And then what's the difference between a histogram and a bar graph? Remember that a histogram represents frequency distributions, and they are going to be drawn together so that there's no gaps. So something like that's fine. All right, so for 6, we're going to look at this pie chart and we're going to answer some questions. All right, so we're looking at top undergraduate majors in 2018. And this is a little hard to see. So let me see if I can color code it really quickly. Okay, so that's hard to see. It should be in color on your end. I don't know. If it's not, everything's labeled, so you're good. So based on the pie chart above, if a university has 5,000 undergraduates, 5,000, how many would you expect to be majoring in psychology? So psychology is 6%, so we're going to times this by 0.06, and we get 300. For part B, for a university population of 1,200 undergrads, how many of the students would be expect to be majoring in politics and psychology? So that's just 1%, so times 0.01, I get 12. And then big number, take that number. How many of those students would graduate degree in social work, criminal justice, or accounting? So I'm going to add all 3 of those up, and I got 7.7%, so times 0.077, and you get this number right here. So just analyzing and being able to do some simple math. All right. So then being able to create a stem and leaf plot is a big deal. So go ahead and try that in 1, 2, 3. Okay. So the mean is 24.75. The median is 21. The range is 45. And standard deviation 13.48. If you don't remember how to find those, go back and watch the videos. I would say that this data is skewed right. If you don't know what I'm talking about, you need to stop and go back and watch the video. Alright, and then we also talked about histograms. So if you look at this histogram, let's answer these questions really quickly. How many cities could have an annual rainfall between 32 and 36? So that's 6 and 7. If I add those 2 together, I get 13. Alright, what percentage of cities have between 26 and 30 inches of rainfall? So that's marked in blue, and that's 3 and 2, so I got 5 on top. On the bottom, I had to find all of them, so that's my numbers in black. So 5, I think it ends up being out of 25, is 20%. Alright, number 9. This is just talking about if you converted from Celsius to Kelvin, what's going to happen to the mean and standard deviation. So you could calculate it if you wanted to. Okay, so the mean, you would just add, let's see, 273.16. So your new mean would be 307.838. The standard deviation wouldn't change because you're still going to be the same amount spread out. So the mean moves, but the standard deviation doesn't. So the whole graph would just shift up. That's all that would happen. So then we're going to calculate the standard deviation. If you do not remember the formula for it, then you need to stop and go back and watch that video. But when you get done, this should be your answer. If you have questions about how to do it and you're not getting the answer, then let me know. Alright, for number 11, we're going to find the mean, median, standard deviation, and interquartile range for the following data set. If you don't remember how to do this, you can go back and watch those videos, but here are your answers. Okay, so here are your answers for these. If you're getting something different, you can message me, but you actually need to go back and watch the videos, figure out how to do it before you take a test and fail it. Number 12, you're going to create a box plot for this data. Alright, so something like that. So remember, you have to find the Q1, the Q2, the Q3. You got to find the minimum and the maximum, and then you make your box and whiskers. If you don't remember how to do that, go back and watch the video. I explained it. Alright, so let's look at some multiple choice questions. Number 1, data were collected in 30 countries on the percentage of women in the workforce. The data was collected in 2000 and again in 2005. Gains or losses in the percentage were the measurement upon which the study's conclusions were based. What kind of design was this? 1, a matched pairs design. 2, an observational study. 3, an experiment using a block design. Okay, so for this one, I would pick E. Only 1 and 2 because there's no treatment, so there can't be an experiment. So only 1 and 2 work for this one. For number 2, a company has developed a new treatment for acne. The research and the development team think that men and women might react differently to the medicine. The researchers separate them into 2 groups. Then the men are randomly assigned to 2 groups, and the women are randomly assigned to 2 other groups. One group of men and one group of women are given placebos. The other group of men and women of the group are given the treatment. The basic design of the study is A, completely randomized, B, blocked by gender, C, completely randomized, blocked by gender, D, randomized, blocked by gender and type of medication, or E, match pairs design. So I would say this one is B, blocked by gender. If you are confused about that, you can go back and watch that video where I talked about the different types. All right, number 3, the principal is planning to do a survey of members of the senior class at your school and want to select a simple random sample. The intended sample size is 40. Which of the following approaches will generate a simple random sample? All right, so I think A, because it's the most random. Write the name of each student in the senior class on a slip of paper and put the papers in containers. Randomly select 40 slips of paper from the containers. You just got to pick the most random one, and it has to be simple. Alright, then number 4, which of the following is important in designing an experiment? Randomization of subjects, definitely. Control of all variables that might influence a response variable, definitely. Use of more than one treatment. That is not required, so just 1 and 2. So D is your answer for that one. So if you look at number 5, which kind of sampling is being used in the final study? Select 5 students from a class to poll about their favorite ice cream flavor by putting all the students' names in a hat and picking out 3 names randomly. So this is C. That's just a simple random sampling. Number 6, do adult Americans support the idea of universal health care? A local television station asked this question to their viewers and then asked them to call in their response. The station was hoping to estimate the proportion of adult Americans that support the idea of a federally funded health care system. The station received 500 calls, of which 290 stated they supported the idea. Which of the following is true? 1, the population being sampled is adult Americans. 2, the sample size is 290. 3, the results are likely to be biased because the survey is not randomly sampled. Alright, so I would pick D, because the sample size wasn't 290, it said they received 500 calls. Alright, so 7, name 3 types of sampling and give an example. The 3 types of sampling we talked about: simple random sampling, like picking names out of a hat. Stratified random sampling, dividing a population of students into groups according to gender, and then picking names out of a hat. 3, cluster sampling. A researcher wants to survey students from Spain. He divides the students into geographical cities and then performs a simple random. So those are your examples, just an idea of that you know what's going on. Alright, number 8. Which kind of sampling is being used in the following? Alright, so divide the class into 4 groups and take a random sample of 2 students. So because you're dividing them into groups first and then you're doing a sample, that is a stratified random sample. So stratified random sample. Alright, for number 9, I'm going to let you read this one. So part A, what's the problem? B, should patients be told which treatment they're receiving? How might this affect their reactions? And C, if patients are not told which treatment, should this experiment be double-blind? So I'm just going to write down my answers really quickly. You can read through them, 1, 2, 3. All right, so here's what I came up with. A, I said no control group. That's the problem. B, no, they shouldn't be told because if patients know which one they're in, then the treatment that could change, and that would be some bias. And C, I don't think there should be a double blind because the patients are measuring the response, not the researchers, so there's no need for that. Alright, so number 10, we're just going to name and describe the type of bias that you might see in each of these surveys. So I would say volunteer bias, and then for part B, I would say selection bias because that's just dumb. Yeah. Okay, and then C, I think non-response bias because people aren't really going to participate. You could argue some different type of bias, so as long as you give, like, an actual answer for why you're right, then you'll still be good. All right, number 11, we're just going to identify the subjects, the explanatory variable, and the response variable. So read through it really quickly. Try it in 1, 2, 3. All right, so I got the subjects were the 5,000 doctors. The explanatory variable was aspirin, and the response variable is the number of heart attacks in a 5-year period. All right, last one. And really, this is just open to your interpretation. So as long as you're putting down something that makes a valid point, it's clear and cohesive, full sentences, you name it, you're good. All right, go back and watch the videos. Follow any formulas. If you're having trouble, let me know before you get to the test. Don't wait till the last minute. I'm not going to answer. Let me know if I can help. Good luck.